Hey everyone, welcome back to AP Precalc. This is lesson 1.1. Let's get right into it. Now, the reason why I initially created these videos is because you guys at IMG will inherently miss a lot of school, whether it's due to sport or sickness or whatever the case may be. When you do miss school, that's totally fine, right? As long as you're just not actively skipping class. Feel free to watch these lesson videos. So if you're gone for 2 weeks for a tournament, watch the videos when you're away if you can, and then you can come back and it's like you won't have missed a beat. These lesson videos are the exact same lesson or lecture that I will give during class. Now, it's still important that you're here a good majority of the days because I give out extra credit for participating and coming up to the board and whatnot. So you definitely want to be here during class versus just skipping it and watching the lesson video afterwards. However, if there's ever a day where you're maybe in class and you feel like we go a little bit too fast, or you're just reviewing for a test, feel free to come back, revisit any of these YouTube videos. They'll be linked to Blackbot and on my YouTube channel the whole year, and you will always be able to watch these whether it's in 0.5 speed where I go a little bit slower, or whether it's in 1.5 speed where maybe you're just looking for a quick review and looking for me to quickly go through all the concepts. Whatever the case may be, these videos are really designed to help you, right? So use these as a resource, but don't become too dependent on them and using them as a crutch, right? Because obviously you learn better when you're in class taking notes, doing everything in person, coming up to the board versus just sitting in your bed and watching these lesson videos back to back to back, right? So let's get into today's lesson. So first off, what is a function? Well, the boring or official definition of a function is it is a mathematical relation that maps a set of input values or x values to a set of output or y values such that each input is mapped to exactly one and only one output value. Now, this official definition is long. You will remember this in a later lesson. Don't worry about it right now. Just know for functions that each input has only one output, right? So for any given x, if we found the corresponding y value, there would only be one y value. Now, let's take a look at these three equations that I have graphed here. Are these functions? Let's go through them one by one. And to do this, we're going to use something that you may have learned in Algebra 1 or Algebra 2 called the vertical line test. And what that is basically we can draw a bunch of vertical lines, and as long as we don't see any given line intersect the equation at more than one place, which none of these do, then this will pass the vertical line test. So this first one, y equals 2x plus 3, that straight line, that would be considered a function. Let's take a look at y equals x cubed plus 1. This still will pass the vertical line test, so this is good, and this would also be considered a function. Now, let's take a look at our third example, this circle here. This is not going to be a function because there are multiple places where it breaks the vertical line test, right? We draw a vertical line and it passes through more than one point. Now, even though at like certain places, like x equals 2, this will only cross through one point, there are still lines that break this exception, so this would be no, this is not a function. So circles are equations, but they are not functions. It's important to get the language right and precise in this class. That's something that you'll see a lot as we get to harder and harder exam questions. Now, hold up. Everything I just told you about the vertical line test has kind of been a lie, and the reason for that is because there is one exception, and the reason why a lot of math teachers will kind of brush this exception underneath the rug when they teach you about the vertical line test is because you literally won't learn about this type of function until the very end of the school year. And these are an example, or this one is an example of a polar function, where obviously there are tons of places where it breaks the vertical line test, but this equation is a function. So yes, it would be considered a function there. We will go more into why this is the case when we visit polar functions and talk about those at the very end of semester 2. Right, now let's talk about the elements of a function. We've said input values, we've said x values. Let's give them a few more names just to get even more confusing, right? So your input values are often known as your x values, right? As we see here, x equals 4 for this example. This is what we call our domain, and also known as our independent variable right there. The reason why it's independent is because x equals 4 is just a random value that we just came up with. That's not dependent on anything else. Now, this is an example of a function box that you may have seen in Algebra 1 or middle school even, where basically we take a number for x, right? X equals 4. We plug it into the function machine or function box. It plugs 4 in for x here. So then we would get 2 times 4 plus 3, right? You evaluate this, you get 8 plus 3, so you would get 11. And then it would spit out y equals 11 as our y value. And this is what we call our range. Our range is our set of y values that we get from any given function. We also call this our dependent variable. And the reason why we say dependent versus independent is y equaling 11 is completely dependent upon what our initial value of x is. If we changed x from 4 to 400, y would no longer be 11. In fact, if you plug it in, it would be 803, a much different number. So y is dependent on x, but x is independent of y. So here our output, range, y values, dependent variable, they kind of all mean the same thing here. Now, when are two functions the same? Well, two functions are going to be the same when they are the same everywhere. And I know that seems so stupid, right? Like, duh. But there are people that will get this concept wrong, and this is a new concept that AP has also added within this last year. So basically, there can't be any exceptions, right? If you stood 10 feet away from your phone, laptop, or the board, right, and looked at this, a lot of people would say, oh, well, these are going to be the same function because they look the same. But wait, there's one exception, which is when you have an input value of 7. At f of x here, the input value of 7 maps to this point right here, which maps to a corresponding output value of 7 as well, right? So for f of x, the coordinate 7, 7 is on that function, or is a part of that function. Now g of x is different, right? The input value of 7 actually maps to an output value of 3, and there's what we call, you'll learn this later on, a hole here. So g of x actually contains the point 7, 3, and so because they even just contain one point that is different, then these two functions are not the same, right? If it was just like this and there was no this point and no hole, then they would be the same function. But because there's even just one point that's a little different, they're not going to be the same. Right? So you will see throughout this course multiple representations of functions. There's 4 main ones. 3 of them you will see way more than the 4th, which is you'll see these 3 a lot more than verbal. So let's talk about each one. Graphical, right? You could see an equation graphed in Desmos. Maybe let's try y equals 2x. Analytical is just equation form. That would just be y equals 2x there. Numerical would be a table. That is, if we have x and y values in a table, 1, 2, 3, 2, 4, 6. That's the same equation just in table form. And then the last one is verbal. And this one's a little bit weird, right? You may see this from time to time, but not nearly as often as the other 3. But what this would look like is if I said for every input value, the output is doubled. That's y equals 2x, right? You take your input, you double it to get your output in verbal form. Now, all 4 of these will at some point probably be seen on the AP test. So kind of like a new pair of shoes, you just got to break them in by getting used to working with all 4 in different types of problems. And you'll see that a lot with this course as well. All right, now let's talk about 2 definitions of image and pre-image. Basically, image is if we have an input value, right? The image of an input value is going to be your single, because every input has only one y value or output value that is yielded or given or produced by the function rule. Now let's take a look on the other side. The pre-image is kind of going backwards. It's where you have your y value and you want to see what x values could give your y value. Now here, remember, every x will only correspond to one y, but that doesn't mean that any y value has to only belong to one x, right? There could be multiple different x values that produce the same y value. That's okay. That doesn't break the vertical line test that we saw before. So let's take a look at this example, right? Y equals x squared, or f of x equals x squared. Here, f of x will always be the same as y in this course. A lot of times you'll see f of x instead. So if we fill in these blanks here, right, the image, right, what is produced from the input value of 3 right here, the image should be this, which is 9. So that would be our answer there. Now let's take a look at the pre-image. Let's find that for an output or y value of 4. Well, when y is 4, which is right here, there are 2 points right here at 2 and at -2. So however, the pre-image of 4 is both 2 and -2, all right? Or you could switch them, doesn't really matter. And so just know pre-image of a certain output could have multiple x values, but the image of an x value will only have one y value. And this is really dependent on the initial definition of a function. All right, so now let's get into a little bit of housekeeping before today's lesson. The first thing is rate of change is a new term that you will see. This is the exact same thing as more commonly known as slope. You've probably heard slope before a lot more in algebra and algebra 2, right? Slope-intercept form, point-slope form, slope equation. That's going to be the same thing as rate of change, which basically just means the steepness of a line, right? This is a pretty steep line, so this is going to have a steeper slope than this, which is a much less steep line there. So this would have a bigger slope than this line there. Now the next thing is writing intervals. We will use the input variable x when writing intervals in precalculus. If we said x is between 7 and 10, not including either, we could either use one of two types of notation. We can use interval, or we could use, inequality notation. Interval notation is where we do an interval, like 7 to 10, and we put curly brackets because we don't include 7 and we don't include 10. Or we could write inequality notation, where x is between 7 and 10, like that. Now, if we said it included them, then an interval, it would be 7 to 10 with the square brackets, or 7 to 10 with an underline to include the values of 7 and 10. Right now, you'll see there's really no difference between those. Now, let's talk about positive versus negative, and when a function is positive versus when a function is negative. Basically, just look at your x-axis here. We take a look, let's take a look at this function, right? And I drew this out. Basically, a function is going to be positive when it is above the x-axis, right? That means the y values are all positive numbers. So this is going to be positive here. A function likewise is going to be negative when it is below the x-axis. So right here are going to be 2 times where this function is negative because it is below the x-axis, meaning all the y values, right, are going to be negative numbers. They're going to be less than 0. So this is when a function is positive versus negative. So let's take a look at this real data, this real graph that I pulled, definitely not AI generated, where we're looking at Taylor Swift Spotify users versus IQ. Here we see as you get closer and closer to the top percentage of Taylor Swift listeners, see the IQ drastically goes way down. Let's label or identify the independent and dependent variable, and then identify whether this whole function is positive or negative. First off, independent and dependent variable. Well, remember, independent is going to be our x variable, and dependent is our y variable because that depends on our value of x. So here, this would be our independent is the top percentage of Taylor Swift listeners, and then our dependent variable is going to be the IQ score. And now, is this function positive or negative? Well, this entire function will be positive because none of the y values are negative, right? None of the IQ score, it's impossible to have an IQ score that goes below 0. And so this entire function will be positive here. All right, now let's try example 1, our first example of the school year. The function shows a graph of piecewise function f over the interval from 0 to 9. Where are all the intervals where the graph of f is positive? So basically, what I like to do is draw a line at the x-axis here, and then basically just look at where is this graph above the x-axis, which is from our x value of 1 to our x value of 9. This is like the portion where it is positive. So I'm going to say there's multiple ways that you can express your answer here. You could say 1 to 9. Now, right now for AP Pre-Calc, I do not care whether you use open or curly brackets for writing intervals. AP Pre-Calc has even made a statement in the last exam to basically say they don't care as well for this unit, right? Now, there may be times where it gets a little bit more dicey and you do need to use the correct notation. Right now, with this lesson, don't worry about it. So either that, or you could say x is between 1 and 9. That's good as well. Or x is less than or equal to, or 9, and then greater than or equal to 1. So either one of these four would be the correct answer there. And I would accept any one of those four. All right, now increasing versus decreasing. A function is going to be increasing when it is going up, right? So as your x values increase, your output values will increase as well. That's going to be this red portion right here. That's when a function is increasing or going up. So increasing just means going up, and then decreasing basically just means going down as you go from left to right. So from if this blue segment right here, as your input values increase, your output values will decrease. That is going to be a decreasing part right there. And then if we take a look from 6 to 8 here, as your input values increase, your output values also increase. That's another example or portion of an increasing graph right there, and that blue is decreasing there. Just know increasing for a function is going up, decreasing for a function is just going down. So example number 2, same graph as before. What are all the intervals of the graph where it is increasing, and then what are all the intervals where it is decreasing? Well, increasing here is going to go from, a lot of people want to say -2 to 3. That would be wrong because it should be, remember, this is an x value of 0 to an x value of 3. So this should be 0 to 3. And then we also need to include from 7 to 9. Both of these portions of the graph are increasing. So end 7 to 9. That looks good. I'm just going to use interval notation. You could also say, if you wanted to, that's fine as well. And then where is a graph decreasing? That just means where is it going down? And that's going to be from 3 to 7. So here, that's good, or that. And again, I don't care if you use curly or square versus less than or equal to, right? They're all going to be the same. Now let's take a look at concavity. This is a pretty new concept, right? A lot of times, a lot of classes up to this point haven't talked about concavity, but you're going to have to identify when portions of graphs are either concave up or concave down. Concave up is pretty easy, right? That's going to be this segment right here, where basically it's going to be an upwards U shape. So U for up, this is an example of a concave up graph. Now, concave down is when it's a downwards U shape, right? And so this is going to be, think of this as like concave down, kind of like that. It's not as easy, but yeah, just think about it as a downwards U. So this portion of the graph is concave down. Now, let's talk about what that means. For a concave up graph, the rate of change or slope of the graph that's concave up is increasing. This does not mean that the function is increasing. It just means the rate of change or slope is increasing. I'm going to show you what that means, so just remember it for now, and I will break that down in a second. Concave down, the rate of change or slope is decreasing. I remember this because down and decreasing both begin with the same letter D, and then up, concave up means the slope is increasing. They like just I remember down decreasing, and then by process of elimination, concave up matches increasing. And anything that's concave down will have a downwards U shape. So let's take a look at a concave up graph. This is concave up, but why? And that is because we know any concave up graph means that the slope or rate of change, I'm going to put ROC for short, is what? It's increasing. So let's take a look at how the slope of this line is increasing. Well, let's guesstimate some slopes, right? So if we take a look and I draw a few lines here, let's guesstimate these slopes. Well, this, I may say, may have a slope, or I'll put M for abbreviating slope, as maybe like 1/2 here, right? It's not super steep, but a little steep. Now let's take a look at this line, right? It looks like a perfect 45-degree angle. I'm going to say that might have a slope of 1. And then this is a little bit steeper. I'm going to say this has a slope of, and I'm just making up random, or not random numbers, but numbers that kind of look right, of 2, right? It's a lot steeper than the slope of 1. And so we see that the slope kind of goes from 1/2 to 1 to 2. Those numbers, 0.5 to 1.0 to 2.0, are going up. They're increasing. That is what we mean when we say the slope or rate of change is increasing. It's getting steeper in the positive direction, right? It's going from 0.5 to 1 to 2 as we just kind of guesstimate these slopes here. So that's what I mean here. And just to show you another example, these lines are just going to get steeper and steeper in the positive direction. Now let's show it with this way, because this is also part of a concave down graph though. And so let's see what happens to the slope or rate of change of this as we go from left to right. Well, we can have this slope here, we have this slope, and then we have this slope here. So just three kind of good example slopes that we can work off of. This may have a slope of 2, right? So we'll use that as our guesstimation for that slope. M is 2. This looks like a perfect 45-degree angle, so we can guesstimate that that slope is 1. And then this has a little bit of not as steep of a slope. We'll guesstimate that that has a slope of 1/2 there. So here, we know this is concave down, just from looking at the shape of it, which means the rate of change, or slope, is decreasing. And we see that here. It goes from 2 to 1 to 1/2 as we go from left to right. And so that means the slope or rate of change is going down in numerical value as we go from left to right over time. That is why it is concave down, even though the function itself is increasing. So that is an important thing. Let me note. F, we'll call this F here, right? F is increasing, right, because it's going up, but the rate of change, or slope, is decreasing. And this basically means it's concave down. So it's important to know, when are we talking about the function itself, and when are we talking about the slopes of the function. Let's take a look at example 4 here. The figure shows a graph of g on this interval. Um, Point A is located at -1, 0, and is where the graph changes concavity. On which interval is the graph of g concave up? Well, we know it's concave down all the way up to this point, and then here is where it switches from concave down to concave up. So where is it concave up? That's going to be from -1 to 5. So that should be our answer for example number 4. Right, now let's take a look at these 4 graphs. When a function is increasing, it's just going up. When a function is decreasing, it's just going down. When a function is concave up, it's going to be an upwards U-shape, and the slope will always be increasing. When a function is concave down, it's going to be a downwards U-shape, and the function is always, or the rate of change or slope is always decreasing, not the function, right? Because as we see with this concave up graph, there's like 2 portions of it. Here, the function is decreasing. Here, the function is increasing, but nonetheless, both parts are concave up. Let's take a look at this graph right here. Here, the graph is positive because it is above the x-axis, right? They have all positive y values. The function is also decreasing because it's going down as you go from left to right. Now, what is the rate of change doing? Well, if we take a look, is this concave up or concave down? This should be part of a concave up graph, which means the rate of change is increasing. So it's important to distinguish whether we're talking about f or whether we're talking about the rate of change of f. This is going to be the hardest part about this lesson, and this is why we do it first, is because it is pretty difficult to just distinguish, are you talking about f or the rate of change of f? Let's take a look at this graph here. This function is negative because it is below the x-axis. It has all negative y values. The function itself is increasing because it's going up as you go from left to right. Now, this function is concave down. It's part of a downwards U-shape, which means automatically the rate of change or slope is decreasing because it is concave down and decreasing there. So it is important to know or like distinguish between these. Right here, g is increasing, but the rate of change of g is decreasing. And that can be true and happening at the same time. Let's take a look here. Example 5, on what intervals is f increasing? Well, here f is going to be increasing whenever the function is going up. We're not looking at concavity, we're not looking at rate of change. We just want to know, where is f increasing? That's going to be from -5 to -1 and from 2 to 5. So that's going to be our answer for example number 5. For example number 6, on what interval is f both negative and decreasing? This is going to be from -1 to 2 is where it is decreasing, right? So it's decreasing from -1 to 2. But where is it negative, right? Where is that function negative? Well, it's negative from -5 to -3. Unfortunately, those two intervals will never overlap. So there is actually no interval where f is both negative and decreasing. So here there's no solution, or you could write no interval. Any of those would be the correct answer for example number 6. Very tricky question. All right, so just to summarize, if the function is positive, then that just means it is above the x-axis here. If a function is negative, that just means the function is below the x-axis. If a function is increasing, that just means the function is going up. This also means the rate of change or slope is positive. This is actually a bad example. Let me draw a little bit of a better one that's just increasing there. If a function is decreasing, that just means the function is going down, so like that. If a function is concave up, that just means it has an upwards U-shape. If a function is concave down, that means it has a downwards U shape. And any concave up means the rate of change is increasing. And any concave down means the rate of change is decreasing there, right? If you can memorize this, then you should answer any question from this lesson. Right, so day 2. So obviously, if you only missed the first day, right, pause the video now. You don't really have to worry about day 2. If you missed day 2, just skip forward to this like next time, I guess, because now we'll go over what we'll cover the next day, which is specific AP exam questions and then just doing more practice problems. It will be combined into one video. Right, so you will see an AP exam question and a question like this in your first quiz and your first test like this, where I will give you 5 coordinates and ask you about a certain portion of a graph. It will ask you 2 different questions, and we'll see an example in just a minute. The first one will ask whether the function f, or whatever it's called, not the rate of change, is positive or negative, and then increasing or decreasing. It will be multiple choice, so even though it's like technically going to be in the short answer section with air quotes around it, you're just going to write the letter of your multiple choice answer. It's weird. This is not asking about the rate of change, it's just asking about the function itself. The second question will always ask you about concavity, and then to determine whether the rate of change is increasing or decreasing. This will be short answer. You'll need to complete both parts of what it's asking for to get full credit for this answer. But it's pretty easy because if you can determine that it's concave up, that always means the rate of change is increasing. And if you see that it's concave down, that always means the rate of change is decreasing, no matter what the graph looks like. Let's go through an example because there will be one of these on your next quiz and test. So here is, and it's always going to be the same exact wording of the question. Obviously, the coordinates will be different, and the interval that I could ask about will be different, but everything else will be the exact same. That's the nice part about the AP exam, is a lot of questions are kind of just copy and pasted from year to year. So we're given 5 coordinates here. Here we're looking at T1 to T2, this interval, which is F is T1, so we're looking from F, and G is T2. So we're really looking at this portion of the graph here. I'm going to almost like extract this portion and draw it out a little bit bigger, where F is -6, 4, and G is -3, 0. On the interval from T1 to T2, so from F to G, which of the following is true? Is the graph positive or negative, and is it increasing or decreasing? Well, let's take a look. The tricky thing is these are not your x-axis. It is important to note that these will not necessarily be your x-axis, those 3 lines there. They are just always going to be there no matter what the coordinates are. So if we're taking a look, here we only have positive values for our y-coordinates, which means this would be above the x-axis, meaning this function should be positive. Now, if it was negative, you may see something like where it goes from -3 to maybe -10 or something like that. You will never, ever see a situation where you go from like, let's say 2 to -1, right? Where you are positive and negative. You will never see that in any question ever, right? I can guarantee you that. So we know this function is positive. Now, is this function increasing or decreasing? Well, if we take a look, this function is going down, right? It's going down as you go from left to right. So this function should be positive and decreasing, making B the correct answer there. So that's part 1. This question will always be the same answer choices. Part 2, on the interval from T1 to T2, so still F to G, determine the concavity of the graph and determine whether the rate of change is increasing or decreasing. Biggest thing here is using a complete sentence and answering both parts. So if we just take a look at that shape, right? Is it concave up or concave down? It shouldn't be too difficult to determine that it's concave down. It's part of a downwards U shape. So here I would want to say H is concave down, if I was writing my answer. And then I would say the rate of change of h is, and then you just want to say whether it's increasing or decreasing. But because it's concave down, we automatically know the rate of change is decreasing. So I'll say, and I'll write out rate of change, right, of h is decreasing. That would be the perfect answer there, and that's what I have as my answer there. That answers both parts, so I need both parts of that, right? If you just wrote h is concave down and you left it there, it would be marked wrong. If you just wrote the rate of change is decreasing, that would also be marked wrong, right? You do need both parts to get full credit for that second portion of the question. So now try examples 7 and 8 on your own, and then we're going to go over the answer. It's the same, just be aware I changed the coordinates that you're going to be looking at. And so let's work through it now. So pause the video now if you haven't done it yet, because I'm about to go over the answer. So we're looking now, same 5 coordinates, but from G to J. So we're looking at this portion of the graph. I'm going to draw it out here, where we're going from -3, 0 to 0, -4. Here, our y values go from 0 to -4. So our y values are completely going to be negative. So we can almost eliminate a and b because we know h should be negative. Now, is it increasing or decreasing? Well, here, the graph is still going down, right? It's going down as you go from left to right, so it should be decreasing, making D the correct answer for example number 7. Now, part 2. Describe the concavity and determine whether the rate of change is increasing or decreasing. Well, the concavity here, this is a concave up graph, right? It makes an upwards U shape. So that's what I'm going to say. I'm going to say first h is concave up. And now that's for the first part there, so that knocks that out. Now determine the rate of whether the rate of change of h is increasing or decreasing. I'm going to say the rate of change of h is, and is it increasing or decreasing? Well, we know any concave up graph, right, no matter what, means the rate of change is always going to be increasing. So I'm going to write increasing here, and that should cover the second part. Now, students love to be lazy. I know you guys. So a lot of students may write ROC of h is just an upwards arrow. This would be marked wrong, right? I would give you no credit for that to cover this portion of your answer right there. So don't be lazy. Write out the full sentence. We'll take an extra 5 seconds. I'm sure you'll be fine. Example 8, different coordinates now. And here we're looking from K to P. So, right, so the different letters that I'm going to ask about, that will change from question to question. K to P, that's going to be this portion of the graph right here, where we are going from 9, -4 to 12, -1. Here, if we look at the y values, we're going from -1 to -4. So our y values are completely going to be negative. But the graph is going up as we go from left to right, so the graph is increasing. So C should be our answer for the first one here. The function is negative, and the function is increasing. Part 2, this is going to talk about concavity. Describe the concavity of the graph, determine whether rate of change is increasing or decreasing. Here, I'm just going to say H is concave, and then blank, and then I'm going to say the rate of change of h is blank. And then these are going to be the two, like, this is like a good template, and those are the 2 blanks you just fill in every time based on the answer. Here, we see this graph is concave down. So that's our first word, right? H is concave down because it's a downwards U shape here. And because it's concave down, the rate of change will automatically always be decreasing. And remember, down and decreasing both begin with the letter D, so that's an easy way to remember your answer there. So that is our answer for example number 8. All right, now let's work through these examples. These, I would say the biggest thing is, and you'll see a multiple choice or 2 questions on this, where you want to ask, is it asking about the function or the rate of change of f? So which one of these is it asking about? The function itself or the rate of change of f? Because that will make a difference, all right? So example 9, the figure shows the graph of function f. Which of the following statements is true? F is increasing or decreasing. That's the first part. And then at an increasing or decreasing rate. This part of the question is talking about f, while this part is talking about the rate of change of f, right? Because it has the word rate in there. So that is important to know. First, let's see, is f increasing or decreasing? It's obviously going up, so it should be increasing. So we can eliminate C and D right off the bat. Now, what about the rate of change of f? Well, this graph is concave up. I can see that pretty clearly, which always means for a concave up graph, the rate of change is increasing. So it should be increasing at an increasing rate, making A the correct answer for example number 9. Now for example number 10, the function shows graph of g. Which of the following statements is true? Here, g is increasing or decreasing, and then we're looking at the rate of change. So again, this is talking about g, and then this is the rate of change of g. So here we see that g is decreasing, right? It's going down as you go from left to right. So we can eliminate A and B. I always like to cross off answers I know are wrong as I'm working through these problems. Just a good multiple choice tip strategy. And then the rate of change, this is concave up, which means for any concave up graph, remember the rate of change is increasing. So it should be decreasing at an increasing rate, making C the correct answer for example number 10. Right, example 11. Which of the following statements is true about function p here? Here, both of these are talking about the rate of change. The rate of change of p is positive and increasing, or negative and decreasing. What combination is going to be true? So here, remember, when the rate of change is positive, this means the function is increasing because it has a positive slope. When the rate of change is negative, this means that the function itself is decreasing because it has a negative slope, right? That slope is a negative number if we had to like guesstimate it. So here, this function is decreasing, which means the rate of change should be negative, right? They're always going to have a negative slope. So we can eliminate A and B. Then, is the rate of change increasing or decreasing? That's going to be based on concavity. So here, this is concave up. So concave up, which means the rate of change will be increasing. So C is the correct answer. The rate of change is negative because the function itself is decreasing, and the rate of change is increasing because the function itself is concave up. Example number 12. Here, the rate of change is positive and increasing, positive decreasing, negative increasing, negative decreasing. This is a little bit off, but that's okay. Here, just know the rate of change should be positive because this function is increasing. So because r is increasing, that means automatically the rate of change is positive. So we can even eliminate C and D there. Those are out of the way. And then because the function is concave up as well, that means the rate of change will also be increasing, making A the correct answer there. All right, so example number 13, which of the following statements is true about function f? Here, the first part is the function is increasing or decreasing. So let's just talk about that first. The function itself should be increasing because it's just going up, right? So we can eliminate C and D, where it says the function is decreasing. And then the graph is concave up or down. This one's pretty straightforward as well. It is concave up because it makes an upwards U shape, making A the correct answer for example number 13. Example number 14, which of the statements is true about g? Here we see that the function itself should be decreasing because it is going down. So we can eliminate A and B here. And then the graph is also concave up because it makes an upwards U shape, making C the correct answer for example number 14 there. All right, example number 15. The graphs of functions f, j, p, and r shown above. Which of the following is the rate of change increasing? Well, the rate of change increasing means what? When the rate of change is increasing, that means that the graph is concave up. So we're just looking for concave up graphs. If we take a look at all of these, we see F is concave up, P is concave up, and R is also concave up. So those three, F, P, and R, makes D the correct answer there. All right, this next example, 16 and 17, use the graph of G below from 16 to 19. 18 and 19 are on the next slide. So here, which of the following statements is correct? Well, on the interval from 0 to 2, the graph of G is positive or negative and increasing or decreasing. Well, if we look specifically from 0 to 2, it's going to be that portion of the graph right there. There it is fully above the x-axis, so the function itself should be positive. So we can eliminate C and D. And then the function itself should also be decreasing, right? Remember, this isn't talking about the rate of change. It's talking about just the function. So it's decreasing because it's going down, making B the correct answer for 16. For 17, which of the following statements is true? Here, they're all talking about from the interval from 5 to 6, which is this portion of the graph right here. G is increasing or decreasing at an increasing or decreasing rate. Well, this portion of the graph is definitely decreasing because it's going down. So the function should be decreasing, making C or D the right answer. And then we're asked to make a statement about the rate. How is the rate changing? Well, this portion of the graph is concave down. So concave down, right, means that the rate of change is decreasing. So it is decreasing at a decreasing rate, making D the correct answer there. All right, next one for 18 and 19, which of the following statements is correct? From 4 to 5, looking at that portion of the graph, which of the following statements is true? G is increasing or decreasing, and is it concave up or down? Well, this portion of the graph is increasing because it's going up, so we can eliminate C and D. And then this is also concave down because it's a downwards U shape. You may have to look in a little bit or like zoom in if you can, but it is concave down. So B is the correct answer for 18. And then 19 from 7 to 8, it's going to be this portion of the graph right there. The rate of change is positive or negative and increasing or decreasing. The rate of change being positive or negative is oftentimes the hardest type of question to ask. But that basically just means is G increasing or decreasing? Here, G is decreasing, which means you're only going to have negative slopes, right, when a function is going down. And because of that, that means the rate of change or slope should be negative. So we can eliminate A and B. And then the rate of change increasing or decreasing, this is concave up. So that means automatically the rate of change should be increasing, making C the correct answer there. So C is our answer for 19 there.